double angle, half angle, and reduction, which is power reducing formulas. All right, first things first, here are the doubles, the halves, and the power reducing formulas. If you are a student of mine, you will have these on your formula sheet. If you're not a student of mine, ask your instructor if you'll be given these. Okay, first example where we're going to use them. If we are given that the tangent of theta is equal to -3/4 and theta is in quadrant 2, find the following. Okay, looks like these are all going to be double angles. I'm going to draw a picture of our theta, and we know it's in quadrant 2. So first things first, we lay out a picture. And theta puts us into quadrant 2. Tangent is opposite over adjacent. And the negative will have to go with the 4 then. Pythagorean theorem is going to produce a 5 for our hypotenuse. All right, using the double angle for sine, we see that we're going to have a 2 times sine theta, cosine theta. So for us here, that is going to be 2 sine cosine. Done with that one. I'm going to keep going with these other ones. For cosine of 2 theta, I can use any of these 3, whichever one I want. I'll probably just use the first one. Okay, for this one, use double angle formula for cosine to write cosine of 6x in terms of cosine of 3 theta. All right. Cosine of 6x is 2 of 3x. So now that means that this is the theta. So it's like 2 theta. All right, using whichever formula we choose. I'll pick this one. Actually, I will pick this one. Done. Next, verify the following identity using double angle formulas. Remember, verifying is we manipulate one side until we can get it to equal the other. So now there's a lot of like kind of guessing and then checking that goes along with this. I typically sometimes pick the wrong method, and then sometimes, since I've done it so much, pick the correct method. So it's really the more you do, the better you get. I'm looking at this. I know that sine of 2 theta is 2 sine theta cosine theta. Not very helpful. And I'm looking at this side thinking, well, that's like the same factor twice. It would have a sine squared and a cosine squared in it. Oh, hey, 1 is sine squared theta plus cosine squared theta. If I rearrange this order, I will see a factorable right? It'll be like a polynomial in nature kind of thing, or quadratic in nature. So here's what I mean by that. This is factorable. Sine theta plus cosine theta. Another sine theta plus cosine theta. Why? Because sine squared plus one sine cosine plus another sine cosine. Ooh, typo right here. Should be cosine theta there too. My bad. Resulting in 2 sine theta cosine theta plus cosine squared theta on the back end. So this is equal to sine of theta plus cosine of theta squared, because there's 2 of them. We've set out to show another verify, so we try to manipulate one side. I'm going to use the identity for the double angle for tangent. Okay, the identity is, just to refresh your memory here, 2 tangent theta over 1 minus tangent squared theta. We divide the top by tangent theta and the bottom by tangent theta. We'll get a 2 on the top. Write an equivalent expression for cosine of x to the power of 4. That does not involve any powers of sine or cosine greater than 1. Okay, there's a couple of different ways to do this problem. Trying to figure out which way would be the easiest way. So the first way that I think of is cosine of x squared, and since we have 2 of them, that would make it to the power of 4. Okay, well, we're gonna go to power reducing. Okay, so I'm gonna scroll over, show you the power reducing. Here's our power reducing formulas right here. And we are working with cosine. So whatever angle is here, we double it when we rewrite it. Okay. So for this problem, not the outside power, but the inside, we reduce it the following way. 1 plus 2x, cosine of 2x over 2, and now this whole thing is squared. Okay. We can square the top, square the bottom, right? Square the top, square the bottom. Top will be 1 plus cosine of 2x, 1 plus cosine of 2x, all over 4. I'm going to distribute the top out. I'll have 1 plus 2 cosine of 2x plus a cosine of 2x squared all over 4. In other words, 1/4 plus 1/2 cosine of 2x plus 1/4. Now this cosine of 2x squared, we're going to use that same power reducing formula again. But this will be a 4x now in there, all over 2. Okay? clean up. Use power reducing formulas to prove this. I'm gonna start with this side. You could manipulate the others, whichever you want. If I break this apart, I can do power reducing here because there's no powers on this side. Right? There's no squareds or anything. So let's do power reducing for the sine squared of 2x. So look at your power reducing formula. And it is 1 minus cosine, and then double the angle over 2. 1 minus cosine, but we're going to double the angle all over 2, like so. If I pull this 2 out front as a 1/2, we will have 1/2 sine of 2x times 1 minus cosine of 4x, and that is what we were setting out to show. We're going to find sine of 15 degrees using half angle formulas. When they want us to use half angle, well, if you look at the unit circle that I've shown in previous videos, then we will see that I don't have 15 degrees on mine, okay? Most of the times 15 degrees doesn't make it onto the unit circle. But I do know stuff about 30 degrees. So if I rewrite my 15 degrees like this, then I can treat this like the sine of theta over 2, that half angle formula, where theta is the 30 degrees. So let's go find that formula. The half angle formula is going to be this one right here, okay? Now with the plus and the minus, you have to pick whether it's plus or minus. You don't put them both. Well, I'm ultimately looking for sine of 15 degrees. I know that the sine of 15 degrees is going to be positive, so I know it's positive. And then the formula. Like so. And now it's just clean up. Cosine of 30 degrees is root 3 over 2. Separately. So we have 2 minus the square root of 3, square root at the bottom, and simplify. And my tip for us here is if you can draw it, if they're describing something that you can visually draw it, it'll help you, it'll expedite all of the work moving forward. So here they tell us tangent of alpha is 8 over 15 and alpha is in quadrant 3. So the first thing I'm going to do is draw a picture. Let's see here, I will go over on the side here and draw alpha. All the way down, and we're in quadrant 3. Now opposite tangent of it, opposite is 8, but it's going down, so that should be negative. And the adjacent is 15, but that's left, so that should be negative, which makes sense that the tangent of it will then be positive, right? Because they're both negative. Okay, little side work to find the hypotenuse here. Negative 15 squared plus negative 8 squared will equal the hypotenuse squared. And we will end up getting 17. All right, now let's answer some of this. So this is for alpha, right? this angle that got us all the way over here, that's angle alpha. So let's talk about what it means to be half. If my angle is between 270 degrees and 180 degrees, and I'm cutting the angle in half, well, half of 180 is 90. Half of 270 is 130. So that means the actual like alpha divided by 2 is somewhere between 90 and 130. I think I said, hopefully I said 135 is somewhere between 90 and 135. So that means that I know the sine is going to be positive when I do that. The cosine will be negative because it's in quadrant 2. And the tangent's going to be negative because I'm in quadrant 2. So I already know the sign that I should get for my answers. Okay? All right, now we're going to use the half angle formula to find each one of these. So let's go over here, remind you of the half angle formulas. I'm probably not going to keep toggling back and forth for these, but these are the ones I'm going to use. Okay? For the sine, obviously this one. For the cosine, I'm going to use this one. And for the tangent, we can pick. It doesn't matter which we use. Maybe I'll just, I don't know. Sometimes maybe not using the square root is easiest. So whichever. Okay. All right. Done. All right. Application problem. A bicycle ramp is constructed for high-level competition with an angle of theta formed by a ramp and the ground. Another ramp is to be constructed half as steep for a novice competition. Tangent of theta is 5/3. This is theta. Okay? Half for novice. Half is steep. Okay? They want to know what is the measurement of the angle for the novice. So what is 1/2 theta, right? We definitely have multiple options for this. Option 1 tangent of theta over 2 is equal to, and we use our formula, sine theta over 1 plus cosine theta, okay? Which means I need to come here and get the hypotenuse. 25 and 9 is 34. So square root of 34. So this means that sine of theta will be and this is what tangent of theta over 2 is, right? Well, if you want to know theta over 2, you would do inverse tangent, and then whatever this is as a decimal, okay? As a decimal, this is 0.5661938, okay? Now, if you look here, the inverse tangent of 0.5619038, theta over 2 is 29.518. 29.518 degrees. That is the half angle. That is the small ramp. Novice. Now, here's another way, okay? Option 2. If the tangent of theta is 5/3, then theta is equal to inverse tangent of 5/3. No, I want to go down one. Yes, inverse tangent, 5/3. Close it. 59.036. So that means the half $29.518. This section was on half angle formula, so I'm sure the intent is to have you use option 1, but option 2 is easier and probably more applicable, like big picture, long-term, other problems moving forward. So.